you are one of the most knowledgeable people in tooling that I know. I very much appreciate you doing this. Will you introduce yourself?
My name is Lluís Miñarro, and I am the CAN tooling segment manager of Hyperion Materials Technologies.
During our last call, you told me about a nickname that you have at Hyperion. What do people call you? You're the can guy at Hyperion.
The can guy.
The crazy can guy. The crazy can guy.
The crazy can guy. Yeah, that's true. I'm so passionate about all the engineering behind a can.
If I'm a can maker, what should I know? How do you help me, or when do I interact with you?
We have many different levels of cooperation with the can making industry. We are a materials company. We know how the cans are made, so we are able to understand the customer's drawing. Depending on the can makers, we may try new grades. We help them to improve the design. We have an agreement with David Lee, with LPS. We work very close together in partnership. We are able to provide from the can design, the tooling design associated to the project, but sometimes we only need fixing a problem with the top wall, fixing a problem, they have a spoilage on the necker.
What is it that you like about the can industry, and what's kept you in here for so long?
There is a lot of people passionate for what we are doing. It's people passionate that is making this industry moving forward. This is a very dynamic industry, and if you are open to learn, to relearn, to challenge what you learned 1 year ago, it's never ending. I'm convinced that we have many things to do in the future, challenging things that the industry needs or will need in the future. That's what makes this can making industry so attractive.
I find that the can industry has a lot of suppliers. There's many generalists, but to have a company that has taken the time and effort to learn about the can manufacturing process and dig deep into it, those are the companies that succeed in the can industry, the ones that really build good reputations. What does lightweighting mean?
It's putting the optimum amount of the aluminum you need in the can. The fillers, they need a container that has to meet some mechanical properties, has to meet some requirements for the filling. So the can makers want to reduce the amount of aluminum they put on the container. You cannot reduce by reduce. You must meet some mechanical properties. You must make sure that the filler will not have problems. So that's lightweighting in general terms.
You said lightweighting, the optimal amount. What does that mean?
If your can line is 30 years old, you cannot expect to be able to lightweight as much as another line that has the latest technology. The best is that you optimize the gauge you use, you optimize the weight of the can you are able to manufacture with the line you have.
So we have an order of magnitude. Can you explain what a can might have weighed 40 years ago and what it weighs today?
40 years ago, we're talking about cans that were lid and body, almost 19 grams. And now, in some cases, we are below the 12 grams for a 211 12-ounce can. There are cans that are lighter than 9.5 grams, and the developments continue to go beyond. Of course, there is room to go, but now, every 100th of gram is a challenge. But that's the beauty of what we do.
If a can maker is thinking about lightweighting, are there any pieces of pre-work?
Sometimes you are making cans and your process is not optimized. So the first thing you have to do before thinking about lightweighting is to optimize the process you are doing today. The guys from the body makers or the conveyors will talk about this. But in my case, making sure that the tools you are using, the design they have, it's optimized to the can you are doing today. And then wait to lightweight. Run the plant the best way you can now. Be focused on that. And then think about lightweighting. If you have a plant that it's not running perfectly, you have a very high tear-off rates, you have high spoilage, or you have certain cans that you are not able to meet the properties. The first thing is to optimize this. Together with tooling suppliers, with OEMs, with engineering companies, all together, work on that, stabilize the situation. Once you are there, then step by step, start to lightweight.
Is it correct to say that lightweighting will only make things more challenging?
When you start to lightweight, you must make sure that the different parameters in your line have wide windows of vulnerability. If you don't, the only thing you are doing is making all those things worse, because with a lightweight, all those small things become more critical.
If you were to look at the can and the body maker, is an example of a window of runnability the allowed top wall variation?
That's a good example. You may be running with your body makers are not well maintained, and then the RAM alignment with the body maker is not perfect. So the risk you have is with a thick gauge, you have no problems with the top wall because of the lack of alignment. The top wall is not so concentric, but you can live with that. But then when you reduce the thickness of the can, this difference on the top wall of the can becomes critical for the necker. So you start to have problems on the necker.
Are there any other pieces of pre-work?
You have to think, are the tools I have consistent with the can I want to make? Meeting the dome reversal pressure I need, meeting the axial load. We get drawings sometimes that are made on the 70.
One might think that this is for a 211, 413. They're fine. It doesn't matter. Why is that not a good assumption?
The tolerances required on the drawings and the way the drawings were defined have been improving in the years, because we have equipment that can meet those tolerances and verify those tight tolerances. Sometimes we see revisions of the drawings and why we made those revisions, why we changed these tolerances, why we changed these angles. Has it still sense what we did? Then another point, not just the geometry, I'm very focused on geometry, but also about the material. We can now be more precise on the carbide grades, more precise on the steel. Coatings, for instance. The technology of coatings for the punch noses or for the clamp rings has tremendously improved.
Is it that if I'm making my current 211, 413 with a thicker gauge and I want to move to a thinner gauge, I will be changing some of the tools and I won't be changing some of the tools? Is that correct?
You have to revise the geometry from the cut edge, the blank and draw die geometry, the drawing geometry, the capper, the gap between the die center and the blank and draw die, and then as well the redraw radius of the redraw die. And in some cases, even the rings have to be updated. And of course, the punch. The punch plays a critical role on the lightweighting. And then the progression on the necking dies sometimes has to be updated because they are very old designs. But of course, the match gap between the knockout and the necking dies has to be changed.
I'm considering a lightweighting project. What should I be paying attention to and why?
Starting on the capper, you must make sure that the cut edge is optimized to the can you want to manufacture. You are making a drawing process, and we must make sure that we are not drawing too much when we are reducing the cut edge diameter to the drawing diameter. So we must optimize this drawing process. The second point is that you should optimize the gap between the OD of the die center and the ID of the blank and draw die. Too loose, you get wrinkles on the top. Too tight, then you get a band where the metal is hardened because you have been ironing the aluminum. Then when you go to the body maker, you may have problems. You have tear-off issues.
Ideally, you want to set up your tooling to result in the correct match gap. If they don't, for example, and there's a match gap that is too large, what cane makers may do is increase the draw pad pressure to decrease the wrinkles. Is that correct?
You cannot push the pressure infinitely because then you will be hardening and then you will have problems on the body maker.
Because in the body maker, you want to have soft, non-hardened metal.
To iron the metal, when it's soft, you need certain forces, but when it's hardened, you need higher forces. One part of the can are different than the ones you need for another part of the can. So you create a differential there and you get problems like tear-off.
So the hardening is not uniform and it's inconsistent.
It's inconsistent. This shiny part on top of the can must be controlled. This shiny part is the part of the cap that has been ironed. If it is too large, as the one you see in the picture, then you have a part of the cap that is soft and you have another part that is hardened. So then you have two different mechanical properties in the same fab. So when you are ironing, you have an issue.
Is there anything else, Lluís, on the copper?
And then, of course, when you are reducing the thickness, the forming radius has to be updated, has to be reduced as well.
Do you want to explain to me why we need to pay attention to the progression when we're talking about lightweighting?
The percentage of reduction you do on each ironing die, it's very important, especially on the third ironing die. That is where you must have a maximum around 40%. When you are forming the top of the can at the third ironing die, if you don't design properly the progression, you are not ironing the top of the can. You need to have some pressure on the third ironing die. You must be sure that you are ironing the top wall of the can on the third ironing die.
If a can maker does not have somebody experienced in doing the lightweighting, when they get to the tool pack and building their progression, what are the common mistakes that will be made?
They are reducing too much on the third ironing die, and then the tear off rate goes up. That's the point. That's the most common thing that happens. The riddle die, first iron die, the second and the third, they go together. Everything must be consistent. You have to revise the progression chart. You must be sure that you are not ironing too much and that you have enough material when you are ironing the top wall of the can. That's a very important thing. And then on the body maker, another point that it's very important. On the punch, you have the lower transition, that is what you have on the left-hand side, but then you have the upper transition. The upper transition is where we are forming the top wall. On the left-hand side, what you see there is the lower transition.
That specific geometry towards the nose of the punch is called the rework taper. Is that correct?
That's the rework taper. And on this part of the punch is where we are ironing. We are reducing the thickness. So there is a point where you start to iron on this area. And this is what we call the first point of ironing. This first point of ironing is different depending on the gauge you are using. You must start to iron at the right place to avoid leaving too much material at the bottom of the can. It's very common that people do not change this geometry. That's critical because if you put too much material, you are selling a heavier can, while this material could be on the trim and then get the money from the trim.
It's obvious with this discussion that lightweighting is a very complex topic. You have a wealth of knowledge and you have worked through many lightweighting projects. You can help with a lot of different pieces of it. Let's say there is a can maker that needs full support with a lightweighting project. Can you walk me through how a process like that might look?
The first thing we need to know is what are the cans they want to make. I want this can with these properties. And then we have a questionnaire. So we start this dialogue and then we prepare with David. Sometimes the design of the can is not 100% clear. So David designs the can. And then from the design of the can, we develop the tooling, define the materials, find the grades.
I genuinely appreciate you spending your time with me here today.
Thanks, Kalvis.
Thank you, Lluís.